Let's go. So this is an Assured webinar from the Assured project. The topic is turning policies into mitigation practices for sustainable smart cities. So this is in line with the Assured project, for which I am the project coordinator. I work for Martel Innovate, which is a Swiss-based company. And I'm joined here with my colleagues from Martel, from DAM, and from UBTech in Greece. A few considerations before that, some quick facts about the project, the Assured project. So Assured is a project that aims at future-proofing of ICT trust chains, sustainable operational assurance, and verification remote guards for systems of system security and privacy. I would invite you to go on the Assured website, project-assured.eu, if you wish to know more about the technical aspects of the project. The duration of the project is 3 years. Well, now in the last year of the project, because we're starting in September 2020, so we're going to last until the end of August next year. Overall, we have a budget of 5 million euros, and we have 14 partners covering 9 EU countries: the UK, Ireland, the Netherlands, Germany, Denmark, Switzerland, Greece, Cyprus, and Israel. Here's our consortium. And here's the agenda for this morning. So as soon as I'm finished introducing you the project and this webinar, then we'll move on to my colleagues Ilya and Dimitra from DAM in Greece. We'll talk to us about smart cities use case in the frame of the Assured project. Then we'll move on to Thanasis, Gianetsos, professor, I should say, sorry, who will tell us about the Assured roadmap. And then we'll have a final session with Dimitris, also from UBTech, which is about risk assessment and policy recommendation engine. At the end of this, we'll have a wrap-up and main discussion session where you can ask your questions and we can respond to them openly. It's a Q&A session, basically. Before I leave the floor to my colleagues, we will be sharing with you a questionnaire, and we really hope and ask you please to fill in this questionnaire. It's going to be put in the chat. I think it's just been put right now as we speak. Yes, thank you, Margota. So please fill in this questionnaire throughout the duration of this webinar. Thank you very much for your help with that, your participation. And on that note, I leave the floor to my colleague Dimitra and wish you all a very nice webinar. Thank you.
Hello, everyone from our side as well. I'm going to be the one to present here our presentation with Dimitra. As also Jean-Baptiste mentioned before, we are part of this consortium of this project that, of course, later on our colleagues from UBTech will share more insights. However, we are here to a little bit introduce the participants to what we are doing in this project. Maybe I can share my screen for our presentation. We have prepared a very short presentation for that. Let me know if you can see my screen.
We can see the screen.
Thank you.
Go ahead.
Thank you. So as we will also discuss later on, Assured is a project that it is based, that the main issue is the domain that it is for this project is cybersecurity. Part of this project, we have 4 different use cases scenarios, and one of them is implemented here in the M that and has to do with the cybersecurity of systems for smart cities. We have been managing this project with Dimitra, and at the moment we are in the mid of our implementation, as you also saw from the timeline that Jean mentioned. The aim of the use case is to test Assured in terms of a secure cross-vertical collaboration platform of platforms with the main focus on public safety. What are the objectives of Assured for the M? First of all, we would like to design and execute a demonstrator. So let's say to have a test environment for a smart city system where we can see what is the application of the Assured technologies that Thanasis is going to present later on for a smart city. In order to do that, we have designed use case scenarios for a system that has to do with a smart city that mainly focuses on public safety. And also, especially our main focus is the security and privacy of city systems, but also to test the exchange of data the exchange of data and the trustworthiness of data sources. So our aim is to evaluate the Azure framework, and this is also related to the questionnaire that you will receive after the end of this webinar. We want to measure if the Azure technology can enhance the trustworthiness of data exchange in city systems. And in the far end, after the completion of this project, we want to create a report with all the outcomes and the guidelines that we can have for cities, let's say, because the other three domains of application of Azure, apart from them, have to do with the cybersecurity and safety of systems from the industry sector, from the smart satellite sectors, etc. So them is part of the smart city case. The reason initially that we were involved in this project is that the fact that, of course, Athens through the M is going through an digital transformation, and tackling the safety and security of smart city systems is a crucial point. This comes from the challenges that the smart city can have in terms of its systems. First of all, as you all may know, especially the participants of this webinar, that they are actually experts in this field, smart city systems are technically complex and perplex. Usually a system that has to do with a smart city or a service is interconnected with third-party sources, and there is a data exchange. So there they can be a point of data breach, or the interconnection with third-party systems can be a point where potential attacks can occur. On the other side, the cyber attacks are actually increasing globally, especially in governance systems. This is something that we all know. And the potential failure of a service that the smart city is offering, for example, VAM, that it is the IT company of the city of Athens, can relate to major problems for the operation of a system. It's of high risk, let's say. On the other side, what a city has to take, the decisions that the city has to take, or its IT company, in terms of the public safety, is of very critical nature, of course. And any kind of mitigation actions in a potential attack in a smart city system has to be real at near time, which is also another point that Azure has arrived to tackle, let's say. And finally, there is a need for a mechanism that can ensure that the data that they are shared among the systems are actually secured and in a trustworthy manner. So this is the scope out of which we are involved in this project. In order to, let's say, shape how we can evaluate Azure in a system, what usually is happening in an EU project, as usual. First, you have to define several kinds of use cases. For Azure, initially, we have defined 7 use cases. Here, you see only 3 of them, because these are the ones that they are implemented in the first period. So out of these 7, we have this criteria to select the first 3 to be implemented and evaluated, and also presented in our project officer. And then we are going to implement another 4 that we are not going to mention today. So one use case that we defined is that as an internal operator, let's say as a city official, I would like to have a complete toolkit where that can take the part of a hub for a public safety and security in my city, so in Athens. And in this hub, I want to have specified accounts and specified access control according to the role that each stakeholder is here to tackle. On the other side, as a system administrator, that the majority of the group that has joined today actually is, I want to have a risk assessment feature. This is going to be also the main point of our webinar today, the tool of Assured for risk assessment. As a system administrator, I want to have a tool when I can be alerted on potential attacks in order to have time to perform corrective actions near real time. So I want to have a tool where it can actually detect let's say, dangerous activity within my systems in order to have time to perform corrective actions. And the final one that we have, the third one that we have implemented for the first period is that an internal operator of a system, sorry for that, would actually like to have a tool where I can review the health state of all the assets of a city system. These assets can be software, can be edge devices, can be other kind of hardware, can be gateways, etc., etc. So I would like to have a complete tool where all the health state of my devices or of my systems are, let's say, prioritized and annotated in terms of their health state in order to be ready to perform countermeasures for cyber attacks. Each of these use cases that of these three, as you can see in the right side, they tackle different kinds of Assured functionality. Some of them tackle the risk assessment feature, some of them tackle the health monitoring, the blockchain part of Assured, and other features that Thanasis and Dimitris are going to present later on. So the general architecture that we have implemented for the Athens demonstrator is the one that you can see here. I'm not going to go into details about that, but the first idea was to create a small lab of a system that has to do with physical safety. So let's say that we have a system in Athens that actually we have installed some smoke sensors where we can see if a municipal venue is in danger of catching fire, for example, or of a leak of gas. Later on, we are going also to adjust in this environment to integrate also cameras, so for the physical security. And this is a test environment that we have developed for Assured. Initially, we have tested Assured through the smoke detector sensors. They are the ones that you can see down here, and you can see our test setup that we did. We integrated these sensors that they can actually detect gas leak, and you can integrate them through as a code with a Raspberry Pi. For Assured, we are going to use Raspberry Pi 3 in our case, and later on, as I told you, we are going to integrate cameras to that with a CC recorder for the physical safety. For example, it can be the physical safety of citizens. What we expect from Assured, we expect to have a runtime risk assessment tool where we can see what security policies we can have on smart city systems. We want to create a simulation environment because, as you can understand, this is something that it is not currently operating in Athens, and even if it was operating, we cannot test it in terms of a research project like Assured. So we want to create a simulation environment to see if such a system can operate in Athens. And from there, we would like to simulate attacks, faults on different kinds of control. For example, attacks to software, attacks to the hardware, to the gateways or to our sensors, attacks to the firmware, etc., etc. Of course, later on, the final idea is to validate if, for example, blockchain, that is a quite new technology and it is introduced by Assured, can be a technology that we can use in Athens and in the M, for example. And in the end, the later vision is to see if Assured can be a tool that it can be necessary for a system in Athens. And I think with that, I will pass the floor to Thanasis to share with us more things about the technical part of Assured in Athens.
Thanks, Ilya. Let me share also my screen.
We can see.
Okay, perfect. So, good morning also from my side, everyone. Thanks again for joining this webinar. So I will try to give a bit of an overview of what we are doing in Azure, and also, highlight and basically introduce you to what is the scope and the reasoning behind this webinar. So as Ilya mentioned, one of the use cases is in the context of smart cities, and we are trying to basically enhance the security of such complex systems. And we also are also like dealing in general with IoT domains, where basically we are having mixed criticality services, service class chain, where basically they are comprising also from complex heterogeneous devices that are trying to achieve this specific service. Smart cities, and more particularly how to provide public safety, it's an example of this. In this context, one important thing that we are always dealing in such system is how to be able to identify the most impactful threats and to be able to define the security policies that best capture the security controls and mitigation measures that need to be deployed and enforced in order to be able to protect such systems. This is one of the core objectives of Azure, of basically actually defining this type of a language for being able to capture different types of security control, and also how to enforce it, okay, and how to deploy it. As Ilya mentioned, one of the technologies that we're actually investigating is in the context of blockchain for being able to also deploy this type of policies. So this is what we actually want to be able to talk about today in this webinar, and also, get your feedback, hence the questionnaire, on the usability of the policy language that we are adopting and we are using in Azure for being able to define such type of security policies. You will see throughout this presentation of what we are trying to capture with this type of policy language. And in the later presentation with Dimitris, you will see a bit more details on the syntax of what we're doing, plus a live demo of the risk assessment that actually provides all of the risk quantification, identification of threats, based on which we are then defining security policies that are expressed through this language. The most important thing, as you will see when we're talking about this type of security policy enforcement and policy recommendation, especially as it pertains to the policy language used, is to be able to actually be usable and applicable in multiple different domains, in multiple different IoT domains. This is actually the most important question, let's say, that, again, we would like your feedback based on today's presentation regarding what we are doing and what we are aiming for in Azure when it comes to this type of security policies. But before we go...
Just a quick note, sorry, yes. Well, your slide was not moving, so I was concerned you were...
No, this was the introduction before I start the presentation.
All good, go ahead. Sorry for that.
So before we actually go now into details regarding the policies, let me give a little bit about the motivation and the background behind what we are doing in the project. So the most important thing that we're trying to answer as a question is how to be able to enhance the operational assurance of all of the systems, as we mentioned, that comprise a target infrastructure, a target system. Now, when we're talking from our side, what we mean by assurance, what we mean by protecting the devices, we are basically talking about protecting the entire application stack of the target device. This covers both networking aspects, but it also boils down and goes down to the low-level system operation of each one of the heterogeneous devices comprising this system, this service graph chain. So we're talking about essentially investigating this new type of technologies in the field of trust computing. Yes, so we want to be able to verify during runtime that all of the deployed devices that are supposed to be working together for providing a service, we have verifiable evidence, we have the necessary guarantees that essentially they're not tampered. Okay, so think of it as an example in the context of smart cities. As Ilya mentioned, we have like one scenario when we have deployed these smoke detector gas sensors that are essentially sending information to the back security operational center to be able to detect if something is going wrong. If these sensors are being tampered with during runtime, then this means that you might actually provide falsified data, which will have like a great impact on the safety of the city. So we want to be able to enforce the most appropriate, the optimized set of security controls in this type of devices for being able during runtime and during also zero-day exploits to attest, to verify the correct operation. Now, this actually question, of course, as you all know, this has been, the focal point of research for many, many years. What is interesting nowadays is that basically we are seeing a shift in the context of the most, let's say, impactful threats. So we are moving away from traditional types of attacks where essentially attackers only, through remotely or through the network, they are trying to compromise the system, bypassing authentication mechanisms, and so on and so forth. So we are actually seeing a bit of a more advanced, let's say, set of attack vectors that are trying to manipulate misconfigured devices, that they are not up to date with all of the appropriate security patches, that they don't actually use the latest cryptographic primitive security controls. So essentially, this means that the attackers are becoming more clever in quotes in being able to attack the system. On one hand, someone can argue that this is to be expected, because when we're talking about a security administrator, essentially we need to be able to protect thousands of lines of codes, multiple devices, where the attackers need to be able to find one only intrusion point to be able to exploit. This is where it gets more interesting and more challenging to be able to identify this type of security policies, especially when we're talking about different types of hardware devices. Yes, like heterogeneous type devices, which is one of the most common characteristics that you can identify in such IoT domains. So what we need in this case is to be able to identify this type of security controls that can enhance security privacy, but also not affect the safety of these systems. Okay, so not to put so much overhead that basically it will take so much time to make a decision of what is happening. So there is this consensus, let's say nowadays, that we need to convert security and safety. Again, this is very, very important, of course, also in the context of smart cities, where, again, with the fire, with the smoke detector sensors, even with the cameras, we need to be able to actually make a decision of what is happening very, very quickly, but with the appropriate guarantees that the data we have collected is secure. So essentially, we need to have new type of security controls and verification mechanisms trying to protect all of the service graph chain and all of the different networking and application, the entire application stack that actually is running inside the device. And this is what we are aiming to do in Azure. Now, there is one challenging part here, what we mean by actually providing this operational assurance in the device. Because keep in mind that nowadays, when we're talking about IoT, when we're talking in general about supply chains, the common denominator is that essentially they actually have much more complex software stack. Okay, so the software is what essentially dictates nowadays the type of functionality and the type of services that is being offered through various devices and the various services. So the question is that since we're talking about convergence of security and safety, can we actually verify the software running the devices? Do we need to verify the entire code base? Or can we actually focus on verifying only those specific code base, specific services that are actually essential for the operation of the device? If we go back to the example of the smart cities, there is a very specific function that is responsible for actually extracting the values for the smoke detector sensor. So if we focus on verifying the correct execution of this specific functionality, which can actually be much faster, will this suffice? And this is one of the most important questions that we are trying to answer in Azure, because this also dictates the type of security policies that we need to construct and compile to be deployed in the system. And this goes in the context of one of the core technologies being investigated in the context of trusted computing. So to be able to verify that a device is behaving as expected, but trying to identify and basically attest and verify only those system properties that are core to the behavior of the device. Because this will make sure, this will guarantee that we can actually have this necessary evidence on the correct operation of the device, but without affecting the performance of the device, which is also another very, very important aspect that we are investigating. And this is where you can see in a different example also, and I added this like intentionally to see like this overlapping security requirements between different types of IoT devices. That even in the context, let's say, of more advanced or application domains like connected cars that are getting much more famous nowadays, and they're becoming the focal point of research. Even in this case, we are talking about of a car be comprised of 1,000 control units that are all of them are connected together. And then the cars are actually communicating with each other, communicating with the backend to be able to have this notion of system and providing all these services like collision avoidance. Also in the context of smart cities, we are talking about identifying parking spots, doing this trajectory mapping in the context of connected cars, intersection management, and so on and so forth. So even in this case, you can actually see that we have multiple different types of devices working together, interlinked. So if one device gets compromised, then basically we're talking about the entire system becoming compromised. And this is where it's getting challenging to be able to actually, again, have the appropriate security controls that we can protect and we can safeguard every endpoint of the entire chain of this whole ecosystem of devices that comprise the service graph chain. So this is, just to summarize, this is the most important thing that we are investigating essentially in the context of Azure, to be able to create this notion of trusted system of systems, of a chain of trust in the entire service graph chain. So essentially to be able to verify and protect each and every device, each and every actor, hardware and software asset that comprise the entire infrastructure. As you will see later on, from our side, one of the most important attack vectors comes to the software, as I mentioned. So we're talking about low-level attestation as part of the security policies. But one of the reasons we selected, as you will see, the policy language we did, is that this should be expandable to also be able to actually have other type of security policies in the context of network security controls, intrusion detection events, firewalls, and so on and so forth. Another important thing here that we are trying to achieve, and this is always where we're having in mind, is that nowadays it's basically we want to have like distributed, decentralized type of systems. So this actually puts another question, another topic of interest in the context when we're having like this type of system. Yes, like it's not only trusting the backend if we are having like the decisions we've done in the security operational centers running on the cloud, neither of only trusting the trust. So we're essentially having now edge in the cloud working in tandem to be able to have the best quality of services that are offered to the users. So this means that devices in the edge with actually systems in the backend, they need to always be able to exchange information or establish a relationship of trust that we need to have the guarantees always during runtime that is correct when we're exchanging data to be able to achieve a specific decision, a specific service. So questions in this case is that, can I trust the edge when it creates the data? And we're having like so many different types of data sources nowadays. Again, consider like smart cities who have like cameras, who have different types of sensors, and so on and so forth. The other question here is that, do I trust the network? Or how can I trust the network to be able to have like, when we're having like a security operational centers running in the backend on the cloud, that is basically can actually perform operations on the behalf of the device, or to be able to actually get the data and have like this correct intelligence to be able to achieve a decision. So we actually have now the two aspects, not only trusting the edge, but how can I also trust the network in this case to be able to perform correctly. And this again adds another level of complexity in the context of the various security policies that we need to be able to identify. So in a nutshell, what's the most important thing that we are doing in Azure is that we are enabling this vision of the zero trust in the IoT. So we don't trust anything, we verify everything before we enable the exchange of data, before we enable the establishment of relationships between the different types of devices running in the edge or the different types of systems running in the backend, and we are continuously monitoring this level of trust that all of the actors, they are actually having the required level of trust to be able to exchange of information, to engage into a relationship before we allow data to be used for reaching a decision. And this is where we are talking about of basically defining a common set of system properties. Okay, so think of it as like defining protection profiles for varying different of hardware devices in the different IoT domains, application domains that we're investigating, based on which we can actually identify the most appropriate security controls that once deployed, we can have the necessary guarantees and the verifiable evidence that all of the devices are actually behaving as expected. And we are trying to do it in this way because we also want to be able to actually have the security controls in a certifiable manner. Okay. So whenever we are actually attesting, verifying the correctness of a system, the output of this operation should be recorded in a way so that any third party, any certification authority, any certification body, or any actually end user, for instance, that is be using the service of the smart city, they can audit, they can verify, they can certify that all of the appropriate security controls have been deployed and enforced correctly before they use the service offered by the system. So protecting the system by doing it in a certifiable manner, these are two of the core innovations that we are trying to achieve. And this is where, again, we are going back to what I started the presentation, that how we are defining the securities and the entire security policy management for the overall lifecycle of the device is a common denominator. It is a very, very important aspect in order to be able to achieve this type of chain of trust in the different devices. So the security policies, and this goes in any system, yes, and of course, like it's the same case in Azure. There are four important dimensions when designing the security policies. First of all, this is what guides the implementation of the technical controls, of the security controls. So this is directly linked and related to the type of most impactful threats and attack vectors that we are identifying through our risk assessment tool, based on which we want to be able to identify security controls. So we're talking about authentication, access control, authorization, the most traditional, let's say, confidentiality, integrity, and how in general we are securing the concept of data sharing. Then we're talking about, as I mentioned, how do we trust the network? So, network control, and to be able to actually react to different types of network events and threats. And the other important thing, and this is like the focal point of Azure, we're talking about low-level system operation. So each one of the devices, including both mobile phones, sensors, program logic controllers, operating robots, we have, like you will see one in one of our use cases, so that they are not vulnerable to software-based attacks. Okay. So this type of software-based vulnerabilities and exploits, nowadays, they seem to be the most prominent type of attack vectors that are exploited by adversaries to be able to manipulate the system. So the second thing, and another important thing, is to be able to set clear expectations. So it has to be very clear with what each device needs to be able to do at each phase of its operation. Okay, so from the moment that we're essentially having a system that it wants to be onboarded, to be enrolled into the overall system, up to the point where basically it's becoming part of the service graph chain, it has to be very clear of what are the security controls, what we need to be able to check, and what it needs to be able to run and to verify before we allow an operation to take place. And this is, again, where we need to have a policy definition language that allows this type of configurability from different types of network controls. Yes, like either at the network level or at the low-level security control. This is where it gets interesting in terms of the security policy, because think of it as like it's like having a firewall. Yes, if we have a firewall and we are only focusing like on one aspect on the network, then potentially we will not be able to actually define the security policies at the lowest level, where a device can actually read, interpret, and react to this security policy in a very efficient manner. Okay, so essentially we're talking about having a more holistic firewall that will be able to actually define all of these different types of policies for the entire application stack, as we mentioned. Third one, help to meet regulatory and compliance requirement. This is also aligned with what I mentioned before about converting security and safety. So when we are talking about defining a security policy, okay, we need to make sure that it is aligned with all of the different standards that we are they are we can identify in all of the IoT application domains, and particularly in the use cases that we are investigating in the context of Azure. And last, but one of the most important things is essentially to have like the security policy that can scale up to the thousands of devices that we are meeting in the context of these domains. And the different types of security policies that we are actually using and we are encountering in the context of Azure, we actually have system-specific policies. Okay, so this is very related to what I mentioned regarding having specific protection profiles for the different types of devices. Yes, so different types of hardware, essentially, that we can use in the context of smart cities and beyond. We have issue-specific policy. This is what we refer to as essentially a policy that is related to an operation that we need to do in a domain application. Again, as an example, consider the most important thing that whenever you want to be able to onboard, to enroll a new device into the entire infrastructure. Okay, so what can we do in this case to make sure that whenever we are bootstrapping a new device, okay, before it's been added to the system, that it is at an expected state, all of the appropriate security patches are being installed, the operating system is at the correct state, all of the functionalities are correct, and then we allow it to actually engage into interactions with the other devices, with the other system of the cervical chain. And then we're having the program policy. This is again going back to the low-level software, each one of the software code base, each one of the software processes that we want to be able to protect and verify that they are correct. Essentially, this is what we want to be able to also go into down to this low-level operation of the device. So this is another, as I mentioned, another important challenge. We need to be able to identify a policy definition language that is able to essentially capture all of these different layers of the security controls. Okay, in this context, in Azure, we are adopting and we're extending what is being called as medium-level security policy language, MSPL. This essentially is an extension of the traditional XML structure-based language that we can identify in multiple different types of other systems. XML is also being used like together with JSON in most of the intrusion detection of the firewalls. You are actually having in most of the commodity computers, laptops, and so on and so forth. Now, the differentiating factor in this case and to what we try to do in Azure is basically try to use this and extend it in a way that we can capture all of the aforementioned factors in the terms of being able to express and configure during runtime these policies based on all of these different types of software, hardware assets, different types of network controls. So essential to be able to capture the different types of security controls that we want to deploy and enforce. Okay, you will see much more details on the syntax and the structure of the MSPL in the second presentation from Dimitris, when we're actually going to do again live demo of the risk assessment, how it outputs the information that then we can use for identifying the optimized set of policies. And essentially, this is, what is the most important question that we want to answer in today's webinar, in the sense that, getting your point of view, getting your feedback, since, especially in the context of smart cities, you are security administrators, you are governing different types of services, different types of applications, to be able to get your feedback on whether such, policy language, okay, could be adopted in real system, as Silvia mentioned, also in the context of smart cities. And what do you think in terms of the applicability, okay, of such a definition language in such complex systems? Okay. Now, in order to be able to actually identify the security policies, a very high level flow of what we're doing is that first, we have the organization, we have essentially the domain security objectives, and we also have a definition of all of the different hardware software assets that can be identified in this type of application domains. Okay, so essentially all of the different components, all of the different actors that are deployed in the context of one specific application domain. Now, based on this, and by fleshing out the relationships between the different assets, so functionality A is installed and is running on hardware asset P, operating system X is running in device Y. So all of these type of relationships, then based on this, we can identify the explicit security objectives that we want to be able to achieve for this specific type of assets. Putting all of these security objectives together, we then go to the layer of a security representation. So we're creating a security profile for the entire application, for the entire system that we want to be able to achieve. For this security representation, then we are actually doing a very detailed risk assessment to identify all of different types of vulnerabilities, threats that can be exploited for penetrating the system, and also, quantify the risk, the impact, let's say, of such vulnerability. So trade-off between how easy it is to be exploited with the impact of this risk. And all of these things actually culminate to the last step, which is basically for this type of security representation that we want to achieve, protecting against these threats, we identify the security controls. As I mentioned, in our case, the focal point is a new attestation task that we want to be able to express, define in the policies, and then deploy in all of the type of systems. Okay, so this is essentially the chain of actions that we take in order to be able to achieve this definition of security policies. Now, you can see here, let's say, a summary of the core innovations, of the core technologies that are being, investigating and we are putting together in the context of assurance for achieving this vision. So the most important I mentioned is the enhanced operational assurance. So this it includes all of the security controls. One of the most important technologies in our case is the attestation. So we have identified new type of attestation schemes and for how to be able to convert every type of device into a security hardened token where we can verify at any point in time, okay, correct configuration, correct operation. I'm not going to go into so much details. I will show you per building block, essentially what is the innovation, a technological innovation, but I will not go into so much details. You can actually see through our website and through our papers as a project and through our public deliverables exactly what new schemes we have identified in the context of trust computing. The second one, it's the risk assessment and the threat intelligence. So we actually have defined a tool for being able to actually do in real time this risk quantification for all of the assets of the target ecosystem to be able to output, again, a risk score per asset that we are then using to identify the optimized set of security controls for being able to actually achieve this. Threat intelligence information sharing, this is where essentially we are also sharing new type of threats. If we're talking about zero-day exploits, we are also sharing all of the different types of security controls, both for enabling other application domains, okay, that have overlapping types of devices, overlapping requirements, to be able to also deploy the same type of security controls, but also, as we said, for certification purposes, for anyone to be able to certify that the system has been protected with a secure way, so all of the correct and up-to-date security controls have been deployed and enforced correctly. Decentralized identity management, this in the context of access control, this is actually a very important feature, especially as it pertains to cities where we are having, police officers, municipality personnel, and vice versa. So people with different types of privileges that want to interact with the system. So we have to be able to also have very efficient access control mechanism. This is where we're going with a new type of identity management, let's say, of being able to interact with this system. And in Assure, we try to also be aligned with this European trend and European initiative on the self-sovereign identity. So actually using the concept of verified credentials for the users to be able to interact with the system. The last two features, safety zone vulnerability analysis, essentially this is where we are considering the latest, the most prominent type of software-based vulnerabilities and software-based memory-related attack vectors in order to be able to identify the appropriate security controls to be able to protect the systems. I think I will skip this also for the sake of time. So you see here a bit of a more detailed, let's say, architectural figure of the entire Azure framework. Again, I don't want to go into details. The most important thing here is for me to showcase like a little bit the flow. So where we are starting, so you can see we are starting here, which is basically the Azure runtime risk assessment. Okay, so this is where a security administrator, a system administrator, and let's take again the example of smart cities. So we're having the system administrator coming and essentially define all of the different hardware assets and software assets that we can identify that are being deployed in the context of the risk assessment. Yes, all of the different cameras, all of the different sensors, buildings that we want to protect. So all of the different hardware and software assets, they're essentially defined in the risk assessment, which then starts performing a risk quantification to be able to identify the most impactful risk and threats that can be exploited for attacking each one of these assets. Now, based on this information, which is also expressed through this MSPL policy, through MSPL language, then this is actually given to this collective threat intelligence engine. Essentially, this is the policy recommendation. Yes, we're giving all this information to the policy recommendation engine that can actually merge them together. The policy recommendation is based on a constraint problem solving, okay, for identifying the optimized set of security controls that minimize the impact of the vulnerabilities in the most efficient, effective manner. Okay, so in a cost-efficient manner. So we can identify like multiple different constraints based on which the policy recommendation will be able to output the best set of results. Once we have all of the security policies expressed through MSPL, this will actually then be deployed in the blockchain, and through the deployment of the blockchain, they can actually be read by each one of the deployed devices. Yes, so we basically have instantiated in each device one agent, okay, that is responsible for being able to reading the respective security policies that are dedicated for this device, and then enforce the policies locally, which basically means that we are then starting to run the security controls, attestation tasks, intrusion detection, and different types of things locally in the device. This is essentially the flow that we are talking about in the Azure. Now, if we take it like per block, just to say it like what we are doing, like the new thing, the risk assessment. The most important innovation here is that we are actually be aligned with the latest trends in ENISA, so CVSS scoring system, and we're also considering like privacy type of threats that can actually affect the devices. And another important feature is that we are not only looking into risks that can directly affect an asset, but we're also looking about identifying attack path calculation. So for instance, if an attacker targets asset A as a bridge, as a first step, let's say, in the intrusion, to be able to then go and attack like another system that is connected, interlinked with the first asset. So this is also something that we are looking and investigating to be able to identify appropriate, attack path calculation graphs between all of the different assets. The policy recommendation, as I mentioned, which then consumes this information to be able to construct, to compile the optimized set of security policies. This is based on multi-factor constraint problem solving. So we identify constraints as an example that we want all of the assets of type sensor, like cameras, like a smoke detector gun sensor, to be able to have the highest security level. Okay, so essentially we need to have all of the possible security controls deployed that are able to protect against identified vulnerabilities. Another constraint for instance can actually be performance. So it also identifies the sequence of how the security controls need to be executed so that we both achieve the required security level, but also not have a huge overhead on the performance, on the resources of the target device. But again, the core innovation here is that we are leveraging and we're applying this type of constraint problem solving to be able to have this optimization on the set of security controls. For the policy deployment, the core innovation here is the use of blockchains for being able to enforce and deploy the policies. The most important thing here is that since we are using like this type of distributed ledgers for the policy deployment, we have this auditability. Okay, so anyone, as we said, can audit how the security policies were created, and basically also check and monitor that all of the devices have correctly read the smart contracts, have correctly read the policies, and have correctly executed the policies in the context throughout their life cycle as part of the service chain. Fourth component here is attack validation component. So basically, this is where during runtime, based on what we are monitoring from the devices, okay, we are trying to actually process this runtime information about the behavior of a system to be able to identify, any new zero-day exploits that were not identified by the risk assessment at the beginning, and for which we need to then update our security policies during runtime and without disrupting the operation of the system to update the security controls to be deployed in the devices. Then we also have attestation enablers. As I mentioned, we have designed new types of attestation schemes, both for verifying the correct configuration of the system, the correct behavior, the correct operation of the system. Another important thing in order to be able to do this is the concept of runtime tracing. Okay, so when we're talking about defining a common set of properties that if we attest, then we have verifiable evidence that the device is behaving as expected, this actually is related to having runtime monitors deployed in the devices in the system that are able to measure these properties. And this is where we have also designed new type of tracing capabilities based only on software without the need of any additional hardware that are capable of measuring, these specific properties that we are interested in per device, per system. TPM-based wallet, so this is basically the wallet that its device has for being able to actually, authenticate itself, for being able to access the system, okay, and interact with the system, and blockchain-based control services. So anything related to, auditable security data sharing, the policy enforcement through the blockchains, we have identified new type of, crypto primitives, lightweight crypto primitives to be able to protect this operation. Now, as also Ilya mentioned, besides the smart cities, we are also considering different types of application domains that have overlapping security requirements. One of our most important use cases is actually on smart cities. Again, the most important thing here is the public safety, but the two very interesting features for us to be able to protect in the context of the project is we're talking about, again, heterogeneous type of devices, okay, sensors, cameras, different types of resources, and different types of properties that we want to protect. And of course, in the context of smart cities, we are always having the notion of privacy. Okay, so whenever, for instance, we have the cameras that are monitoring the citizens, we need to be able to actually use this information for making a decision, but this information needs to be protected for any privacy leakages and should be only accessed by authorized personnel. Okay. This is a very important feature, and this is where all of the different type of, assured blockchain access control and privacy preserving crypto were tested to be able to achieve this balance between security and privacy. We are also having one use case in the context of smart manufacturing. So think of it here is that when we're having one manufacturing floor, essentially we're having multiple different types of systems and robots that they are working together. And these are actually managed by human operators. So what we are interested here is to be able to protect the safety critical application of how to be able to avoid accidents, okay, for the human operators, for the user that are moving around in the manufacturing floor by the robots. So if a human operator is getting closer to a robot that is working, the robot should be able to actually stop immediately so as to avoid any accident. This basically means, so the core service in this case is that we are having all of these different program logic controllers equipped on the robots, and they are exchanging information regarding the location of the workers as they are moving around. Okay, these are being sent to a centralized system, to a gateway, for instance, where it combines this information and needs to make a decision whether a robot needs to stop, okay, so as to avoid accidents. In this case, of course, you understand this is a very safety critical application, and the most important thing is to have guarantees that the data being monitored regarding the location of the workers by the devices, they have not been the result of tampering. Okay, so these are not falsified data. So we need to have very, very strong guarantees regarding the correct operation of the specific software running in the robots, okay, regarding the location extraction and the location monitoring of the devices, and also for the software that is responsible for governing the operation of the robot to be able to be operational during any time, at any point in time. So this is where we are essentially talking about stress testing all of the different type of attestation mechanisms we're talking about. And another interesting part here is when we're talking about security policies is that always throughout the life cycle of a factory, it can be the case that we are deploying new type of sensors. Okay. So we need to have also security policy of what happens when we're talking about onboarding new type of sensors and new type of devices in the system. The third one we are having in the context of smart aerospace. So this is actually another very safety critical application domain. And the most, let's say, core functionality, the core feature that we are aiming for securing here is the concept of a remote update. So currently what happens is that when an aircraft goes up into the, a public aircraft goes up into there, and then it comes down, a system administrator, let's say, they have to go physically, manually there to extract the data to be able to check if everything is okay and if any maintenance is to be done. So essentially, we want to be able to actually now enable this remote maintenance of all of the different components of the aircraft, which basically requires the secure exchange, first of all, of the data, the secure extraction of the data from the different control units into the aircraft, and also, if needed, the secure and authenticated software update in any type of the control units comprising the aircraft. So again, we're talking about security policies that pertain to threats that can affect the establishment of the authenticated channel between control units and the backend control system, and how to be able to actually have up-to-date software patches to be deployed into the aircraft. Last use case is in the context of smart satellites. This is, of course, a bit different from the previous one. The most important thing here is that when we're talking about smart satellites, we're talking about exchanging payloads and mission payloads from the ground station into the satellite. This has to actually be very well protected with strong keys, and we need to have like a very strong, secure and authenticated communication channel between the ground station and the satellite. So the focus here is essentially about defining security policies regarding usage of keys, key refreshment, and so on and so forth. So putting all these things together as the last step before I give the floor to Dimitris, okay, it's basically if we try to put all of these security and trust requirements that we want to achieve together, this is where essentially we have the question of the type of security policies that we want to achieve. And the questions that always we need to be able to answer for any type of application domain is that what the security control need to be able to protect against, where each security control needs to be deployed. Okay, so we're not talking about having one security policy as a holistic policy deployed everywhere. We need basically to have like different type of security policies, different type of firewall rules of events to be able to actually be enforced and be executed in different positions in the overall system, yes, in the overall infrastructure. Then there is a question of between which node we need to have this establishment of trust before they interact. This is linked to the relationships that we need to establish between the different actors, when the security controls need to be activated. So when we are monitoring and when we're tracing things taking place in the network, in the device, when do we trigger that the security policy being executed, being enforced? And last but not least, what additional elements, this goes back like what exactly is the protection profile of each one of the devices at the end of the day that we want to protect, and by having a profile that has all of the appropriate security controls, that if these are enforced correctly, then we are sure we have the guarantees, we have the evidence that the entire system is being executed, is behaving as expected. So the MSPL, again, just to summarize how this works as a flow, okay? You can see it here on the top left. So essentially, this is an XML structure that we can define what. So we have the subject, which is the actor, that is able to do an action on a specific object. And the nice feature of this type of structure is that we can identify, basically this field type represents a security control. So we can actually define different types of security controls network security controls, attestation security controls for the same subject, for the same actor, for the same device. Okay. So this very simple, let's say, structure written in XML provides this high level of expressibility, of accessibility to be able to capture all of, again, the different type of security controls. And again, you see here all of the steps that take place, and you will see live with the risk assessment. So we are having actually, providing all the information about the assets in the risk assessment. So we are creating the asset cartography. Based on this, we are then, appraising, let's say, the attack vectors. We're identifying all of the vulnerabilities, the threats for all of the identified assets. And this is where we are creating a risk quantification graph for the entire architecture, based on which we essentially have a risk level for each one of the assets, representing the impact of each one of the vulnerabilities, so as to identify those ones that are most impactful and we want to be able to protect against. Based on this, then, we're identifying the most appropriate, let's say, we do a mapping of the different possibilities of security controls that can protect against these threats. All of this information is then given to the policy recommendation, which basically will determine the security controls that are then deployed through the blockchain. And we are having also this right part, which is the runtime, as I mentioned, if something is identified during runtime. So if there is a triggering of a security policy, we are also collecting the events to be able to identify if any zero-day exploit was tried to exploit by an attacker, to be able to identify an up-to-date security policy. I think I will also skip this because this will actually be by Dimitris. So this is my last slide to also close as a summary. Essentially, what Assured is aimed for, it's basically providing, the appropriate security enablers for this vision of the next generation of system of systems, where we are talking about completely distributed services, completely distributed systems comprising of heterogeneous devices. And the most important thing is the concept of zero trust. Okay, so we are moving into an era where basically this concept of zero trust, that we want to verify everything at any point in time, it's becoming very, very important. Okay, so Assured aims to provide, let's say, the proof of concept, the first set of core security controls that will be able to establish this vision. But as you can understand, we are still having a lot of work to be done, especially in the context, again, of converging these two worlds, yes, of security, privacy, and trust with safety. Up until now, these two directions, were actually running parallel. Now we have reached the point of converging these in different application domains, also considering the 5G and the 6G. And, we still have a lot of work to be able to do, so as to make sure that, security does not compete with safety, but also safety does not compete with security. And I think with this, I will conclude my presentation. I don't know if we take questions now, or we also allow Dimitris to do the presentation, and then we open up the floor at the end for any questions.
I think we will continue Thanasis with Dimitris. And a reminder for all participants, please put your questions in the chat. And don't forget, from the chat, you will find the questionnaire to fill in the questionnaire that we ask all participants to fill it in. Dimitris, the floor is yours.
Thank you. Thank you so much for the thorough presentation. Can you see my screen, everyone?
Yes, we can.
Perfect. So, let me give you a short introduction to what we're going to see in this part of the presentation. We are in the part called the risk assessment and policy recommendation engine. So the focus will be a bit on the technical aspects and the demonstration of this part of the architecture that Thanasis presented to you before. So this part is highlighted in this dotted purple box that you can see on my screen. Actually, the risk assessment part, working in tandem with the collective threat intelligence and forecasting engine, is the part that connects, if you like, the edge environment of the deployments, meaning the actual devices of the environments which are being deployed and being monitored, to the cloud backend of Assured, which is responsible for offering all this kind of intelligence for the policy enforcement. So the risk assessment actually is there in order to collect all this kind of information coming from the environment regarding the assets, collect also information when it comes to evidence about threats being applied on the assets of the deployments, and building an asset cartography and conducting the risk assessment process. Based on the risk assessment, a risk graph is generated and is delivered to the policy recommendation engine, which is then responsible of delivering this sequence of attestation and of attestation tasks that need to be executed on the devices so that to ensure the appropriate level of security. In order to do so, UBTech have worked in the context of Work Package 2 in order to deliver a specific risk assessment methodology. So the risk assessment methodology of Assured has 7 steps, including also the initial step, which is the scope and domain definition. This is where the risk assessor actually will take the first step in order to define the scope and the outcome of the assessment, considering the environment and what we are trying to achieve. The first step is the analysis of the environment. As we said before, the risk assessment Assured deals with different use cases like the smart cities use case, the smart aerospace, and so on. So the risk assessment methodology is agnostic when it comes to the environment which is applied to, and this is why we need to take these specific steps. So the first step is the analysis of the environment, where actually the environment is being examined and being decomposed in order to identify all these kind of business processes and the assets that take part in this environment, considering also their interrelations, as we will see later on. In the second step, we focus on the threat analysis. We conduct a threat landscape in order to identify which kind of threats may be applicable to the assets taking part in an environment. But also, this can be done either based on the knowledge of the risk assessor, either by capitalizing on specific components like the tracer that we have in Assured in order to collect actual evidence on threats that happen on the devices. The third step has to do with the vulnerability analysis, where actually this is where we identify if there are vulnerable assets that can be attacked on the monitored environment. And by having all this kind of information set it up, then we proceed actually to the impact analysis so that to identify if an individual asset can be affected by this kind of threats and vulnerabilities. We perform the risk assessment, which is derives a risk report, meaning we derive the risk graph, as I said before, and then having this state of the environment, the risk state that reflects actually the level of trust of the environment, then at the last step, we are in position to apply mitigation steps in the form of controls. This kind of controls can be any kind of controls like the consideration of patches for vulnerabilities, the consideration of actions in the context of standards, security standards that can be applied in the business processes of an organization, or in the context specifically of Assured, as we do, and we will see it, the application of specific attestation tasks that can regulate and control the execution behavior of software and hardware components in the topologies. The risk assessment component of Assured is based on Ubitec's risk management suite called Holistic. Holistic provided the baseline in order then to expand and build the risk assessment artifact for Assured. Holistic provided had the beneficial features for providing efficient asset inventory management, to being synchronized always with specific sources of information like the CV, the CP, the CWE in order to acquire threat intelligence-based information from these kind of repositories known in the domain and in the community. It has features for providing live information about newly disclosed vulnerabilities. It has different tabs where we can add configurable security intelligence tools. It can provide a quick risk level analysis on asset basis, as we will see, in order to provide an overview of the whole topology, but considering each asset individually. It is aligned with the NIST common vulnerability scoring system in order to provide the risk quantification required in order to perceive, the risk level of each asset. As we will see, it is a complete tool that can provide personalized dashboards in order to report all these kind of risks and evidence. It uses a state-of-the-art technology in order to provide a graph to illustrate all this kind of information. And of course, it can be integrated with other solutions as it provides a specific complete API and can help in order to provide risk mitigation plans. So Holistic was the baseline for us. This is a closer look to the loop that we have built in the context of the risk assessment architecture and depicts how actually the risk assessment part works in tandem with the security policy, the recommendation engine, in order to deploy and enforce the policies. So considering the environment, all this kind of information about the asset cartography, vulnerabilities and threats and data sharing flows are entered into the Holistic front end from the security officer. And then based on the internal modules that perform the risk quantification or the attack path calculation, the Holistic engine performs the risk assessment. This information is exchanged with the collective threat intelligence through the Kafka component here. So the Kafka component plays the role of the intermediate part, enabling the exchange of messages between the two parts. Given this, and after having actually also the result of the policy recommendation engine, the policies that we want to enforce are sent to the backend engine of Assured, so that to be enforced in the environment in the form of smart contracts. And then the loop happens again in the sense that whenever we see a policy violation that may happen and may be collected by the Assured tracer, then this cycle of event is triggering again and again in order to ensure that always the monitor environment meets the trust levels that we need to meet. So just an overview of the functionalities offered by the risk assessment. We have a graph-based vulnerability and threat modeling. This is a feature that enables to the security administrator to have an overview about the deployed environment. As we can see here, this is an example of an interdependency graph where all the software and hardware components being connected in an environment are illustrated in the form of a graph, namely the interdependency graph. The interdependencies that we can define in this environment can be not only digital by utilizing, for example, the is connected to or is installed on relations, but can be also, logical or denoting that a piece of data is processed by another process or software or hardware. It can be even physical, if we want to say that something is located somewhere else. In general, the interdependency graph is an abstract model that enables us to illustrate with a high degree of freedom any kind of relation in an environment, so that to be able to track any kind of cascading effects that may happen between the assets. The next feature functionality of the risk assessment, of course, is the conduction of the actual risk assessment, which is the cybersecurity risk assessment methodology, which empowers this part. So Holistic have been enriched with a specific methodology in the context of Azure. We have utilized the CVSS vulnerability scoring system version 3.1, which is the latest one, and we have different ways in order to calculate the risk levels. In fact, we have 3 different risk variations, which is the individual, the cumulative, and the propagated risk level, so that to cover the risk assessment from multiple perspectives. We have, in addition, introduced the privacy impact scoring system, another novelty of Azure, where actually we are able to translate how a vulnerability score, how a vulnerability can affect the privacy of individuals when it comes to data of individuals that may be part of the topology which is being monitored. Another feature is the attack path calculation. Intuitively, as we can see in the first figure, what we are trying to do is that we are able in position to identify the attack paths which are generated through this topology and the graph that I mentioned before. So we are able to identify entry points and see whether the attacker, based on the vulnerabilities on interconnected assets, can actually jump from asset 1 to asset 2 to asset 3 until it reaches a specific sensitive security or safety sensitive asset. In this way, the security officer can take specific controls and specific decisions so that to cut these possible attack paths and ensure that the security level of the overall topology will be sustained in a high level. The last point, of course, and this is actually the focal point of this webinar, is the policy enforcement that can be done in the form of controls. There are specific templates that the administrator can fill in order to express this kind of policies, which is at the back end are translated in the MSPL language, as we will see later. So this is exactly what we wanted to do. We had a platform where the security officer can govern the overall topology and manage it, but we had to find a way in order to convey the necessary information about the threats, about the attestation policies that we want to deploy, among the different technical components of Azure. So in order to achieve this and to both meet the criteria of having a language that can be able to enable the communication between machines, but also sustain the expressibility and the human readability of the policies, made us to convert to the utilization of the MSPL policies, the MSPL language. So the MSPL is actually this kind of structures, as we will see, that are sent to Kafka from the risk assessment component, then are taken into consideration in the process of the policy optimization, and then again in the using MSPL format are being conveyed to the other components that will translate them into smart contracts so that to be deployed at the end of the topologies on the devices. So Thanasis previously mentioned about the qualities, most of the qualities of the MSPL language. So we had to find, and we allocated, we pinpointed this language in the literature as being able to express security policies regardless of the underlying technology. Just because we had also to cover the spectrum of all the use cases of assault. So the language, as we said before, can define subjects that act on objects based on specific conditions about the actions and the requirement, and we can also accompany these actions with additional information that can characterize the policies that we want to deploy. So it provides us the necessary level of freedom in order to define this kind of policies that we need. So as Thanasis presented to you before, MSPL provides this level of freedom to us and keeps the expression of policies to be simple, to be expressiveness, to have extensibility in the terms that we can add, if it is necessary and depending on the case, new fields and new substructures in the policy in order to express new things that we want to be deployed and considered in the policies, and will enable us to build this kind of interoperable operation end-to-end in the assured environment. So the structure, as we will see, before jumping into the actual demonstration of the tool, just keep in mind, we will come back to these slides, that the general structure of the MSPL outcome that you will see is that we will have a set of attestation task list that is going to be actually enforced in a specific asset in order to be sure that this asset will maintain the required security and trust level regardless of the vulnerabilities that this asset may have. So this is this will be described through these pieces, these structures, the attestation task list and the configuration rule, as we will see later. So let me jump to the tool and we will come back to this later. Can you see still my screen?
Yes.
Perfect. So this is the environment of the risk assessment of holistic. Here in the dashboard, actually, the security administrator can have an overview of the whole security posture of the deployment which is being monitored. Having a heat map, for example, in order to see which are the threats and the vulnerabilities currently in the overall being applied in the overall topology, and have critical information about the risk assessment results. So the most important and first step is the documentation of the assets. As we can see in the assets tab, we have a thorough list of the assets comprising the environment which is being monitored. With the visualization tab, we can see the interdependency graphs that depict how all these kinds of critical devices are being connected to the deployment. So for example, in the case of the DAM use case, we have highlighted that we have this kind of smoke detectors or the IP cameras that take part in the surveillance concepts that the DAM pilot is serving. So, for example, we have on a central server the connection of smoke detectors, and the smoke detectors on them have installed the smoke detector sensor firmware and a software for extracting the values, the specific values of the smoke detector. In addition, as you can see, we have the server which manages the IP cameras which are being connected on it, and the IP cameras have a specific firmware running on them. In this example, you can actually take a taste about how this environment is constructed. The administrator has the ability to add new assets. So, for example, we can add one new IP camera here. Let's say another camera. We can define the business value, meaning what is the level of sensitivity that this asset has. In our example, we place it as very high, which is the privacy sensitivity that this asset may have. Very high because the camera can actually take images, videos, even sound of individuals. And then we can define here the relationships with the rest of the assets. So the IP camera is connected to the server. In this way, we submit it, and we can see in the visualization board that we have added a new IP camera connected to the server. In this way, the administrator step by step can create a digital reflection of the actual environment so that to control it, as we will see, to manage its vulnerabilities, the threats, the controls, and the policies to be deployed on the environment. So, in order to make all these kind of steps, in the Open Intelligence tab, we have several tabs like the vulnerabilities. Here, as I said before, holistic comes integrated, connected to synchronized, with online sources like the CVEs, having the latest CVEs being published. And what the security administrator is doing is actually to create this kind of attack scenarios, meaning that, for example, we have defined here some example attack scenarios saying that the server asset has this kind of specific vulnerability. We know that based on evidences that we have collected from the topology or based on the knowledge of the security administrator that the server is vulnerable to this specific vulnerability. The smoke detector is again vulnerable to this specific vulnerability. So based on this, the security administrator can define these kind of relationships in the context of the attack scenario. Having identified these scenarios, what we are trying to do in Assured is to provide the means and the ways to control these kind of vulnerabilities. And this is actually where the controls tab comes into play and enable us to deploy the attestation policies that Thanasis mentioned before thoroughly. So in this example, we have defined that a control flow attestation will run on the server so that to mitigate the vulnerability that we have identified previously on the attack scenarios. The same applies for the second control where configuration integrity verification scheme will be applied for the server to mitigate the vulnerability. And again, a configuration integrity verification will be applied to the smoke detector values extractor software, which is running on the smoke detector. These kind of controls, attestation controls, actually can be configured. I don't want to spend more time on this, but you can imagine that when we are applying a specific control, we need to define specifically a name, if it mitigates a vulnerability or a threat, to the individual asset where this attestation task is applied to, the level of security that we need to achieve, or the resource that to be attested. So meaning the critical part, the critical piece of software that we need to attest and get evidence about its operational assurance and integrity. So given this, we define this set of controls and attestation policies to be applied on the devices. After taking all these kind of steps, we are ready to conduct a risk assessment. Let me recall that the risk assessment outcome is sent to the policy recommendation engine that will then, based on these controls that we have applied, will define the proper sequence of actions, the proper sequence of attestation actions that will be executed on the devices. In order to do so, these two components are communicating between Kafka. Here is the environment of Kafka where we can see actually the messages which are being transmitted, okay? So let's see here, let's see the MSPL policies topic and monitor it and see that the message that will convey the information about the risk assessment will be sent to Kafka. Let us execute a new risk assessment. Okay, a new risk assessment has been executed. And here in the tab, you can see that the risk assessment has been executed and a new message has been delivered to Kafka so that to be captured then and be consumed by the policy recommendation engine. This is the MSPL format of the message. Let me beautify it a bit so that to take a look over it. Here is the whole result of the risk assessment, meaning that in the MSPL format, the holistic provides a complete structure of all the assets taking part in the risk assessment. Let me here focus specifically on, let me get back to here because I have it more clear here. As I said before, we have the attestation task list and the configuration rule being presented in that part. So for example, for the server, as we said before, we have expressed the need in order to perform configuration control flow attestation on the secure data extraction process. That was the resource to be attested. And we expressed also the need in order to perform configuration integrity verification on the binary unpackaging process, focusing specifically on the offsets in the memory denoted here. So this part is the part that denotes which are the attestation tasks to be executed on the server device. And later on, we have, after that part, we have the configuration rule, which provides also the necessary information about the existing vulnerability and the threats on the assets. We have the mapping of the vulnerabilities and the controls to be applied so that to mitigate this kind of vulnerability. We have the verifier ID, which denotes which device will be the verifier that will initiate the attestation process to be executed. We convey also the information when it comes to the vulnerability scoring so that to be considered in the process of the security policy manager and consider how critical is a vulnerability. And last but not least, to denote what is the desired level of security and trust that we want to achieve on the specific asset, meaning the server. Okay, so this is the information which is being conveyed to the security policy manager from the risk assessment tool. Then at the back end, the security policy manager has been executed and has delivered an attestation policy in the specific topic of Kafka to be deployed in the form of smart contracts. So this is the execution, the outcome of the execution of the policy recommendation engine, where actually depicts what the sequence of actions, of attestation actions that has to happen on the specific device, so that to sustain, to meet the desired security level that the risk assessment process implied in the previous step. This can be seen more clear here in my slides. Actually, what the policy recommendation engine says is that you need to execute the configuration integrity verification attestation scheme on the binary unpackaging process as a first step, and having as a verifier the server. This is the server ID here. And then as a next step, to execute the configuration integrity verification on the smoke detector. And finally, after having executing these two kinds of tasks, attestation tasks, you will be able to execute in a safe manner the process of extracting the values from the smoke detector. In this way, the policy recommendation engine actually enforces and instructs a sequence of actions, attestation actions, and operational actions that needs to happen on the device in order to be sure that the specific level of security and trust that we have defined will be met. So that was it from my side as a demonstration from the whole flow of the tool, from the risk assessment part and the introduction of assets and data entry in holistic, until the part where policies are generated just before the enforcement step on the devices. And this is now the part where we actually need your feedback and to trigger also the discussion among us about all this process that we have showcased to you, and to give us also your feedback when it comes to our questionnaire. The link for the questionnaire has been pasted in the chat, so please take a look to your chat. And in the questionnaire, you will see some questions actually trying to get your feedback when it comes to the usability of the tool. Consider that you are the security administrator of the IAM and you want of your organization, and you want to deploy policies and express policies so that specific actions will be taken and check specific security and safety critical processes taking part in your organization. So this is a kind of a small example of the questions that are going to be filled by you. For example, requiring your feedback about how easy it is to operate the tool, if the MSPL provides this kind of expressibility and configurability that we need to meet, and all this kind of information. So thank you very much for your time.
Thank you very much, Dimitris, for this very thorough presentation. I think you've covered a lot. So as of now, we don't have any question, but please, if you have any, drop them here in the chat. The key thing, please, all participants, fill in the questionnaire. The link is on the chat. as mentioned by Dimitris, Thanasis before, Ilya and Dimitra before, please fill in the questionnaire. That will help us in our work. On that note, I think maybe Thanasis, a few mentions on the next step, the key steps of the project until the end. And if we don't have any questions, then we can just close the webinar. Thanasis.
Yes, let me also thank everyone from my side for attending these webinars. Again, if there are any questions, please put in the chat or raise your hand and we can have a discussion. Where we are now is basically, as you mentioned, Jean-Baptiste, we are entering basically the last part of the project. Okay? So the project is expected to finish in August 2023. So essentially now we are 2 months away, 3 months away, basically, of finalizing the second and final version of all of the components of the Azure framework. Hence, your feedback to this questionnaire will also allow us to do any necessary updates that in the security policies and the policy modeling and in the policy language definition. So our plan, yes, is by March, the final version of the Azure framework will be finalized, and then we will be starting the second round of experiments of all of the components in all of our use cases, including also, as Ilya mentioned, the smart cities. In the first round of experiments, we had focused also a lot on the smoke detector sensors. Now we'll be focusing also on cameras and testing the new type of tracing capabilities that our partner NVIDIA is also creating. And the plan again is that we will be able to finish all of the experiments, all of the evaluation by around June, July, and then we will wrap up the project with the key takeaway messages, as we also mentioned about where we are in this vision of securing the next generation of system of systems and what still needs to be done in this research field.
Yes, and also from our side, maybe I would like to add up that what we have presented as an example of a system for physical security with smoke detectors or with cameras is just an example in order to test the functionalities of Azure and do, let's say, a stress test in a system that is of high criticality. Of course, this framework, I think that the participants of this webinar can, we actually call them to envision this framework even in other kind of systems that it is not so much of high criticality, for example, like a camera that actually monitors citizens. Other kind of systems that they are developed within an organization or other organizations related to smart systems that they are not, let's say, not so much criticality. Our aim was initially to test the extreme part of Azure in such a system, but maybe we call here our participants to see how this can be applied and to actually evaluate the features even in the system that they are already managing for Athens, for example, for the city of Athens.
Thank you very much, Ilya. All right, so I will thank all our speakers today. Thank you very much, Ilya. Thank you, Dimitras. Thank you, Thanasis. Thank you, I think we will close this webinar now, a bit ahead of schedule, but that's perfect. Quick reminder, please fill in the questionnaire. And on that note, I thank all the participants. Just to let you know, the webinar will be recorded, and recorded will be put on the website, the project website. So the project website is project-assured.eu. And just that Assured project, you will find it, no problem, on Google. Thank you very much, everybody, and wish you a beautiful day.
Thank you.
Thank you very much.
Thank you all.